Okay, I think you see it.
Yes, I do. We can probably go ahead and get started. So Stefano is giving a talk from the NIRSpec GTO team called Probing the Epoch of Reionization with the most extensive Cycle 1 JWST NIRSpec program.
Okay, thank you. I would like to organize you for these nice conferences. I'm Stefano Carniani. I'm postdoc at the Scuola Normale Superiore of Pisa. And in this presentation, I'd like to give you just a general overview about the NIRSpec GTO program and what we are going to do in the first cycle of JWST. Okay, yes. So part of the program is also be done in collaboration with the NIRCam team. And currently, both teams count more than 50 members. So the result, the slide that I'm going to show you now are from the work from this large and growing group. Here, I'm going just to talk about the NIRSpec part. I think the NIRCam part will be discussed by Brent. And as you can see, in the GTO program, we cover different topics, but most of the time is dedicated to the galaxy assemble. In particular, we're going to use the integral field spectroscopy mode and the multi-object spectroscopy mode to study the galaxy evolution across the redshift. So I just start from the MOS mode. So I think you already know how it works. So the idea is to use the 2050, 100,000 shutters in the multi-shutter array to target our galaxy, redshift galaxy, and get their spectra in just one shot. In the GTO program, the idea is to use 3 shutters for each target, and then we adopt the nodding scheme to subtract the background emission. Okay, you can see the example in the bottom figures. You can see the 2D maps before and after subtracting the background emission. And this scheme is mainly used for the survey, the very high redshift, higher than 5. For the surveys targeting lower redshift target, lower than between 1 and 5, we are going to use 5 shutters to take in account the extensions of the galaxy and to study the emission along the y direction. Just to give you an idea what we can do with 3 shutters, this is one simulation targeting the ultra deep field. In one shot, we can observe up to over 200 galaxies with the prism, and some results you can find in the paper Bachelard 2019. Here you can see the spectra. If you observe this field for about 28 hours, so you are able to observe galaxies with very low star formation rate, about 1 solar mass per year, that represent the bulk of the galaxy population. These are redshifts. You can see the continuum with high signal to noise. The GTO, we're not interested all in the prism, but we're going also to use the grating, both R1000 and R2700. Here you can see the count rate map for R1000. So we use the same mask of R100 because we want to use the observation with the grating mainly to study the nebula lines. So we don't care about overlapping spectra because there are not so many emission lines. So once that we have the redshift from the prism, we are able to disentangle the emission from different targets. About the surveys, in the MOS program, we have 3 surveys: the deep, medium, and the wide. The deep and the medium are done in collaboration with the NIRCam GTO team, and the survey is called JADES. And here, the main goal are very high redshift galaxy, higher than 9. But in particular, we are going to observe all galaxy redshift higher than 3 to study their properties, the emission lines, and so on. As I said, the program will be done parallel with NIRCam. So you can see already seen this figure in previous presentations. So the idea is to have a pre-imaging with NIRCam and then a follow-up with the NIRSpec. Just to show you a general idea, this is the scheme that we are going to use for the good south. So initially we observe with NIRCam. NIRCam will be the prime instrument, and with NIRSpec we observe galaxy selected with by JWST. Then we follow up with NIRSpec to observe. So once that we analyze the NIRCam observation, we select, we make our MSA mask by using the NIRCam observations. Then we have the wide survey. This is we don't use, it's not in parallel, but this is just based on current catalog, particularly it's based on JWST catalogs. And the idea is to have a very large survey, 31 pointings, to reach a large number of galaxies of target. Here, mainly we are going to select galaxy between redshift 1 and 5, and as I said at the beginning, we are going to use 5 shutters because we want to study the line kinematics along the y-axis. Here you can see the number of targets as a function of the sensitivity in the prism at 2.5 micron for the 4 surveys. The medium, I split the medium in two programs, and within the brackets you can see the exposure time for the prism and for the grating. So in total we are able to observe more than 10,000 galaxies. For the medium and for the deep survey we are going to use the prism and the 3 bands at R1000 to cover all the wavelength range between 0.6 and 5.2 micron, and we are going also to use the R2700 in band 3 just to observe to study the H-alpha line. While for the wide, we are going to use the prism and the 2 bands at R2700 to as I said, to study the line kinematics and the properties of the nebular lines. So this is what about the MOS. As you can see from the figure, we have also several hours for the integral field spectroscopy mode. In this case, the idea is to study the properties, spatially resolved properties of a redshift galaxy. For the cycle 1, we already selected 43 galaxies between redshift 3 and 9.1. We saved several hours also for the cycle 2. And generally, we are going to use R100, R2700 to study both the stellar emission and the properties of the interstellar medium. And we are going to target both star-forming galaxy, normal star-forming galaxy, and AGN host galaxy. At redshift higher than 5, say 6, we for star-forming galaxy we mainly select a galaxy already observed with ALMA, since the synergy between these two facilities allows us to obtain to fully characterize the properties of this redshift population. With ALMA, we are able to study the cold, gas, and the dust emission, while with JWST, we are going to probe the emission of the warm gas and the emission of stars and their distribution in the host galaxy. So, but in general, with the GTO program, with the extensive program, we are going to study the evolution of galaxy at high redshift, in particular redshift higher than 2, where so far we have only little information, we'll say little from a spectroscopical side. So indeed, most of the observations done so far at high redshift have been done by imaging, and a few targets have been observed with ALMA or by UV emission lines. So one of the main topics of the program would be baryon cycle and the metallicity, and studied within the Epoch of Reionization. So far, with optical lines, we know very well the relation up to redshift 5, and we have some studies that use ALMA redshift higher than 7, but these suffer by large uncertainties and the low statistics. Another important thing is about the kinematics of the gas. So a lot of things have been done at low redshift, and recently with ALMA it seems that the gas is less turbulent, what we expect from low redshift observation. However, we cannot compare ALMA observation with the ground-based observation as like Symphony or MOS, because they trace different gas phases. One, with the alpha, we are going to trace the warm ionized gas, while with ALMA, we mainly trace cold gas. So the idea is with the GTO to extend the work up to a redshift, even at redshift 7, and see indeed if rule out or support the current scenario suggested by ALMA observation. Then still about kinematics, the idea is to study the outflows. With the depth of our observation, we're able to see the broad components, both in star-forming and JWST galaxy, and to study also the presence of outflow in faint star-forming galaxy by using the stack technique. It would be one of the large chances at a very high redshift. And with IFS, we can also see the first evidence of feedback, in which we expect to see star formation, the region of star formation, of ongoing star formation, anticorrelated with the outflow region. Still about feedback, the idea is to also to see we expect also to see a lot of passive galaxies. This is a recent work by Santini 2020. We expect in JADES to observe at least 10th galaxy with the prism. So a lot of scientific objects. So we want to do with GTO. So I've just described some of them. So I just go to the conclusion. So we have 3 surveys with the MOS, more than 900 hours. We observe more than 10,000 galaxies. Currently, for the cycle 1, we are going to observe 43 galaxies with the IFS mode. And some of the field will be delivered with the high quality spectrum. Still, we don't know which one, but we will deliver the list soon. Okay, thank you.
All right, thank you very much, Stefano. So we'll wait a little bit to give people time to write some questions.
So I might jump in and ask the first question that we've got here. I think that actually Brant has maybe just answered the question. The question was, can you say a bit more about the timeline for public release of the data? And I think Brant has answered that in Slack, saying the public release timeline for JADES depends on the scheduling. I can address this in more detail.
Okay, yes. So what I can say about the NIRSpec part, so what we can do is just to deliver also the fully calibrated data, so the spectra fully calibrated, both for the prism and for the grading, at least for a few fields.
Okay, there's no other questions, but I will ask one. I sort of maybe have an idea of the answer too, but I'm just curious what your plan is. Do you plan to update your target list sort of until the last minute, or do you think you all are pretty set with which sources you're going to put slits on?
Okay, for the MOS, so the idea is depending on the shadowing, so the position angle strongly limit our choice, our selection. But however, the priority list more or less is already defined. So, and for the IFS, at least for the cycle 1, everything is already plan is already scheduled. So for the cycle 2, we have to plan, we have to schedule in the next month.
Okay, all right. Well, thank you very much for this great talk. And if you have more questions for Stefano about the NIRSpec program, please put them in Slack and he can answer them there.